What if you could answer an ancient burning question by playing a musical instrument? Since the Greeks first introduced the concept of the music of the spheres, the idea that the movements in the cosmos could be described musically has captivated humankind's deepest thinkers and inspired some of the world's greatest works of art, science, and philosophy. 400 years ago, Johannes Kepler famously laid out his 3 laws of planetary motion. Most people who know about Kepler think of him as the father of modern astronomy, who proved once and for all that the planets revolve around the sun in elliptical orbits. What most people don't know is that Kepler made these scientific discoveries through music and a relentless pursuit of truth, and a conviction that everything in the universe is governed by rules of harmony. Rather than blindly following religious dogma, he was one of the first to insist that mathematical models of reality should match observational and empirical data. What does the music of the spheres sound like? And how does it feel to be immersed in it as a multiplayer immersive game where everything that is seen and heard is generated by the beautiful harmonic motion of our solar system and beyond? Concordia is an entirely new kind of musical instrument that feels like a video game while teaching advanced astronomical concepts. It will be an open source, growing, modular instrument created and played by the community in their own custom cockpits.
Hello, everyone. I am Mary Liz Bender, and I'm so excited to introduce you all to Kelly Snook, a dear friend of mine and founder of Kepler Concordia, which is the main subject of our conversation today. I'd really like to hear from you. How on earth did Kepler Concordia come to be?
First of all, Kepler Concordia is just still coming into being. So it is a process, and it's been about 19 years now, this journey. So I'm just going to talk a little bit about the journey. But before I do that, I just want to say, first I want to acknowledge the enormous privilege that we have to be talking about these things, to be thinking about these things, especially in a time like this, that we're coming together to talk about humans to Mars and art and science and beauty and exploration and the destiny of humanity. And at the same time, there's this real tension with what's actually happening in our real world. And it's important to me to acknowledge that. So Kepler Concordia has been a very slow burn for the last 20 or so years of my life, during which I was working at NASA for about half that time and then working in music technology for the other half. I'm constantly in this learning process, trying to understand how all of this fits into that larger context of making the world a better place. I like not to lose sight of that. So the Kepler Concordia Project has evolved through all of these different twists and turns of my career as I've been trying to figure out how do we make the world a better place, and then what role does science and technology and art and music play in all of that. How Kepler Concordia came to be was I was working, so back up just for a minute, just to give some context. When I was a little girl, I thought that my thing was music and that I was going to be a musician. Both my parents were musicians. My family was just full of music. There was music all the time. I wanted to do music, but then as I got older, that prospect got more and more scary to me. And it got to the point where it was so scary that I had to just decide I wasn't going to do that, and I was going to do something else. There wasn't really anything else that was obvious to me, so I just kind of randomly chose aerospace engineering, not out of a burning desire, as I do. Such was the extent of my fear about music, was that I went all the way to PhD in aerospace engineering.
Wow.
But during that time, I was working on music and always doing music on the side. And at some point, I started working at NASA, and I decided that I needed to learn how to produce music. And so for a long time, I was doing music production and learning music technology in my recording studio. And then I was working at NASA in the science and engineering at NASA. And that was exhausting because I was doing 2 different things. And in the middle of all that, I was invited to give a talk, a speaking tour actually in Japan. This was 2001. So I had just been working at NASA for a couple of years. I had just started doing music production. So I was in the beginning stages of both of those things. And I was invited to Japan to speak about the mystery of space and man. And this title, this title is daunting for anybody. They wanted me to talk about how, in history, how astronomy impacted humanity's collective understanding of ourselves.
Wow.
And, that would really required me to zoom completely out and think about this idea of space and space science and astronomy affecting us, our whole psyche. And so I had to do a lot of preparings because I had some serious imposter syndrome about that speaking tour. And so I started studying and I started reading up about Kepler, and I was reintroduced. I had learned about Kepler's mathematics, but what I rediscovered or discovered, I'm not sure, was this idea that music was not art, music was not entertainment, music wasn't a tool for expressing yourself. What music was in Kepler's time was one of the tools for exploring reality. So along with arithmetic, geometry, astronomy, and music, those four things comprise the quadrivium. And I thought, wow, how is that possible? And then I realized that Kepler had made these discoveries in science that he's famous for, basically launched modern astronomy through music. And not only through music, but through music and spirituality, both of which were not really seen as legitimate pathways for investigating reality. And this was just blew open my world, and I was super fascinated by it. And that just started this slow burn. Like, I had a sense that the key to what would really light me up was somewhere in there, trying to figure out, how did he do that? How did he use music this way?
This was so interesting to me when I first discovered Concordia. I did not really know this about Kepler myself. You said something that really stuck out to me in one of your other interviews. You said that Kepler gave glimmers of a world free of the Venn diagram we've forced ourselves to be slave to. Can you speak to that a little more?
Yes. And the time when I discovered him and his work, rediscovered him and his work, and really started thinking about music in this new way. In my world, especially at NASA, there was a science world, which is actually a different world than the engineering world and human exploration world. And then there's a world of a kind of ideas and innovation and invention. And then so when I was trying to figure out how to bring these two things that seemed like separate things at the time to me, this music and this engineering, how to bring them together, I felt very much that. I felt as a slave to that way of thinking, like, okay, well, where does this fit? Because I had to write an application. I had to write a proposal to NASA to propose why it was I wanted to go to the Media Lab to try and figure out how to sonify the universe. And so they asked me a question in the application, something like, I should go back and find it, but it was something like, please describe your career up to this point and how this assignment will fit into NASA's strategic goals. And so I tried to, in answering this question, I realized, okay, well, I need to write a Venn diagram because my career has been like science and some engineering and the overlap between science and engineering. But then there was like starting these global organizations with the UN and the ideas and philosophy. And so there's going to be an ideas bubble. And then I'm looking at it and I realized, okay, since I'm not really being honest with myself, I realized this was the point where I needed to be authentic. And I needed to say what I thought was true rather than what I thought they wanted to hear. And I didn't think they wanted to hear about art, but I found the courage to put art into this Venn diagram. And when I did that, I noticed literally everything that I'd done was, I could plot it in this Venn diagram and I could find, and most of the things were in overlapping areas, but what I realized with the juicy bit was right in the middle, and I put the word goal. This was a breakthrough for me, just to think that it was possible to not worry about which box it fit in, but to use all of these different things together. And if I were to be really authentic in that Venn diagram, there would be the spiritual bubble as well. And that was what was so exciting to me about Kepler, was that that Venn diagram didn't exist in his time. The science didn't even exist. He invented it, and he invented it through music. So,
it's really fascinating. Okay, at this point, you are so inspired by Kepler. You've discovered your life mission. It's coming to light, at least.
It's glimmering. It's a little glimmer.
I want to talk about the next step that came to you. And you have this analogy that you used of shaving a yak. Maybe that will help if you can kind of explain.
The peer pressure was high at NASA not to think about things that were kind of already solved. So planetary dynamics is pretty much solved. Why would we want to create a sonified solar system? That just sounds, that doesn't sound like there's any science there. Like that just sounds like fun times. Since the peer pressure was so high, this was low, slow burn. This was like try every so often to read Kepler's book and fail and then put it back on the shelf. But like think about it every night when going to sleep, but just not actually doing anything about it for many years, for decades. And part of that was because, first of all, I didn't really know even how to think or talk about what it was that I wanted to do. I just wanted us to use music as science, but like that didn't exist. And the technology, in fact, didn't even exist at that point to do that. So conceiving of what it was at all took many, many years and just patience with the slow burn. So I wrote that proposal. I made that Venn diagram. NASA accepted the proposal and they sent me to the MIT Media Lab. And that was where I learned about this concept of yak shaving. So yak shaving is when you have a thing, we'll just call it the thing. It's a task that you want to do or something that is your goal. But in order to do that thing, you have to do this other thing. And the other thing may or may not be directly related, but it's in the critical path of that thing. But in order to do that thing, you have to do this other thing. In order to do that thing, you have to do this other thing. And sometimes there's a chain of things that you have to do that's so long that by the time you get to the end of it, you're shaving a yak. So yak shaving is really a term for really important things that kind of have nothing to do with the main thing, but you have to do them to get to the main thing. Mm-hmm. And when I encountered this idea, it suddenly made me relax because it made me feel like, okay, first of all, I don't know what the thing is, but I know that it's there. But what I need to do is just learn how to recognize the yaks when they come in and also learn how to recognize other hairy animals that aren't yaks that are just going to distract me. And so, there were a lot of those hairy animals, and I'm still working on distinguishing between the two. But as I started shaving yaks with the specific goal of figuring out what the thing was, then the thing started coming to life. But this was this was really important concept for me.
Yeah. So what was the first yak after discovering that mission? Where did you go?
Right. So I went to the Media Lab, and I was still a NASA employee, but I was at the Media Lab as an innovation ambassador to try and understand what made the place innovative. And then to bring that innovation back to NASA. That was my goal. So I basically had a chance to just spend time learning stuff and also doing some meta-analysis about what caused innovation to happen. And so the first thing I was really focusing on while I was there were the tools that would be required to do data sonification, because I knew that if I was going to want to use sound and music to represent data, I was going to need to learn something besides Fortran 77, because that was the only tool I had in my box at that point. So at the Media Lab, there was all sorts of cool stuff, new stuff going on.
They're still using Fortran.
They are, and I love it. But it doesn't quite do all the jobs that are going to be required to do this thing. So I spent quite a bit of time just learning new tools, learning new programming languages, and then I also just finding the communities of people that were doing these things. And the data sonification community was amazing. A lot of the yaks really were focused in that time at the Media Lab, where I encountered people that are doing really great data sonifications. Like my friend Joachim Gossman made a beautiful sonification and visualization that was interactive, the Mandelbrot set, that caused a transformation in the way that I understand fractals. And this really excited me because suddenly, and it wasn't music, but it was sound, and I could use my ears to understand math. Like, whoa, that was so exciting. I was like, okay, I want to do this, but I want to do this with the whole universe. And so then the next yak was meeting Tarek Berry, who had built, this is before the days of Unity and, VR worlds. But he had created for himself a musical instrument that was in 3 dimensions that you would fly through. These objects would make sound, and as you place the objects in space and then fly through them, every time you fly through is a kind of slightly different path. The music is different. It's like a 3-dimensional interactive musical instrument. And so it started just like these pieces just started falling. Okay, so I want to do that, but I want that all that stuff you're flying through to actually be data.
Cool. So here you are at the Media Lab. You're immersing yourself in this amazing community, getting inspired by the other tools of creation that they're using. And then somehow you end up working on these absolutely beautiful gloves that I've come to seriously know and love. Tell me about how you came to engineer the MiMU gloves.
Yeah, so this is even still one of my biggest yaks, and my favorite yaks. Is super big and super hairy, and I love it. This really is the piece of the puzzle for me with the MiMU gloves is, if you're going to be immersed in this data, if you're going to be immersed in a solar system that is sonified, where you can interact with it, and everything that you see and hear is information. I want to actually have a way of interacting with that and playing that like a musical instrument with my gesture. And so for me, just the interactivity part of it was a big piece of the puzzle. And while I was at the Media Lab, I invited Imogen Heap to come and visit. She came and visited. She got really inspired by my friend Ellie Jessup's glove that she had created. And just the idea that you could take sound and then manipulate it with your hands. That was what she was looking for. And she went back to the UK and immediately started working on it. And I went back to NASA. But in the meantime, I'd gotten married, and my husband needed to go to the UK. It created an opportunity at Imogen's invitation to come and work on new musical instruments with her, and work on the technology side of what she was trying to do in her studio, which was really ambitious. Yeah, so how it came to be is that we started trying to use what was on the shelf to achieve what she wanted to achieve, and it just didn't exist. And we realized if we were going to create a tool that would free her from her music technology and allow her to do what she wanted to do musically, we were going to have to create it ourselves. We learned very quickly that she wasn't the only one that wanted this. Once she started talking about what we were doing, lots of people wanted this for a lot of different things. And we realized the universal appeal of it. We weren't really doing anything new, but after we created the gloves, we realized, wow, we should try and make these available to lots of people, not just Imogen.
Thank you.
And it's really exciting. We've just been doing that since. So we've been working on it for 10 years now. And so they've gotten to the point where people do have them in their hands, on their hands. And yes, it's really, really exciting. We're starting to do more things with them. And I know you've been thinking about taking them to space.
What I love about what you all did is that you made electronic music not stiff and robotic, but organic and human. And when I think about the International Space Station or, building new communities on other worlds, I think, how can we make it beautiful? How can we take our humanity with us? Because that's what's important. And so I always saw these gloves as the perfect tool for bringing our humanity to the stars. And I know it's not just music we can manipulate. It's art in many ways. It's sound. It's also robotics that we can control. There's beautiful science like what you're doing. So there are these lightweight, perfect tools of creation that I desperately want to get into space. But as an outsider, from my perspective, I just feel like you're so purposeful in everything that you do, from music making to the technology that you create. It seems to me, as I kind of look at your whole mission, that you're really concerned with the evolution of our species. And I feel that in one regard, you're pushing us ahead with the technology that you create, and in another, you're helping us get back to the root of our intuition, if you will. Does that speak to you? Do you feel like that is accurate?
That really resonates with me, yeah. I often feel like I'm creating a future that's a return to the past when music was a tool for exploring the universe. I really want to live in a world where music is used that way, that we don't just use it as a plaything, but even more that it's part of a broader capacity to immerse ourselves in information about ourselves and about our universe that will help us understand who we are, help us understand each other and connect to each other, help us to understand our oneness, to understand those things that are common to all of the reality, like music and harmony, harmonics and energy and vibration are pretty much at the heart of all physics and all engineering and even all human experience. And so a tool like this I really hope will help us underscore and understand our oneness and experience it very viscerally. And what really excites me about Kepler's work is that he came to the same conclusion at the end of his Harmonies of the World, which is where he laid out his laws of planetary motion. He essentially wrote a prayer asking God to help us live in harmony, to mimic the harmony that defined all of reality, and to love each other and to recognize our oneness. That was super exciting to me, that a scientist in 1619 would be writing that. And I, it really made me realize how much we've divorced our science and our engineering from our humanity. And I think this is something I'd like to help change.